So are you done with writing the definition, angular speed?
Yes, sir.
And you write the relationship, angular speed omega equals del theta by del t.
Yes, sir. Writing.
Then after writing this formula, you write the side note I gave here. You write it down, okay, bottom of this equation. You see, I gave you the side note here. That side note you write here at the bottom of this equation, angular speed, where we will get the relationship of linear speed and angular speed in terms of radius.
Yes, sir. Yes, sir. Done.
Till V equals R omega, you are done, right?
Yes, sir.
Very good. Are you writing nicely? Hello?
Sir, I mean, it's not the best it can be. I'm rushing a little bit.
You should write nicely so that when I need, I can see it. Okay, you should have a thick physics notebook. Okay,
Okay, sir. Yes, sir. Yeah.
you
From
should.
next class,
If
I'll
you
have
don't have, you buy it and you
copy.
retake the
Yes, sir.
notes. Okay, it's
Yes,
very
sir. I would.
important to take the notes. Otherwise, you'll be in trouble later because every day you'll get some notes that's very important. Now, centripetal acceleration, right? It is subtopic 12.2 related to centripetal acceleration. So can you read this part? Don't write, only read.
So which part?
Yeah, from
Which part?
an object.
Acha.
Loudly,
Wait.
please.
Uh, Say from an aircraft.
An object. An object traveling. Are you seeing the screen?
Acha, wait. Yeah, yeah.
Centripetal
Acha,
acceleration.
yeah, I'm saying. Yes, sir. An object traveling in a cy- cycle may have a constant speed, but it is not traveling in a straight line. The velocity is continuously changing, as velocity is a vector, has magnitude and direction, and its direction is changing. A change in velocity means the object is accelerating. The acceleration is towards the circle center of the circle. That is why it is called the centripetal acceleration. In order to make an object accelerate, there must be a resultant force acting on it. This force is called centripetal force. The centripetal force acts towards the center of the circle in the same direction as the acceleration. This means that the centripetal force always acts at right angles to the instantaneous velocity of the new object.
Okay, instantaneous is velocity means is the velocity for a certain moment. Okay,
Yes, sir, right.
particular
Yeah.
moment.
Mm.
And for a particular moment, it is straight, right? It has a direction.
Yes, sir.
And we have this diagram. We should draw this diagram. After writing this heading, centripetal acceleration, you draw this diagram. Huh?
Yes, sir.
Are you done with drawing?
Sir, almost.
Yeah,
Sir,
you
should I
see
write?
here.
The
Here we
label
have
also?
labeling this arrow, direction of force and acceleration. Okay, this arrow you should show. Huh? This is center, direction of velocity, path of ball, and in figure you write a ball is in circular motion. Okay, just you write a ball is in circular motion.
Yeah, okay, sir. Sir, where is Asan?
Asan, I already sent the message to him. I don't know. Yeah, he's coming. Yeah, I saw him. Asam,
Yes, sir. I'm joining.
yeah. So you missed some notes. You should take them. Huh? Angular speed. This definition you write. Then this mathematical relationship you write. Then you write this relationship with an arrow. We said we showed it in the right side. You write it just bottom of this equation. Okay. Hello, Asam. Have you understood what you have to write? Hello.
Listening.
Then you write acceleration. Huh? Cent-
Center. centripetal
Centripetal acceleration we are yes,
acceleration.
centripetal acceleration we are doing, and here is the diagram for centripetal acceleration. You should draw it, draw a level. Yeah, now you continue here, Navid.
Okay, sir. At any instant, the direction of the ball's velocity along the tangent to the circle figure on page 3. If the string breaks or is released, there is no longer any tension in the string or no centripetal force. The ball will travel along the direction of the tangent to the circle at the moment of release. Again, if an object travels at constant speed v in a circular path from A to B in time del t, where va and vb are velocities at point A and B respectively, then acceleration A is equals to del v by del t.
Okay, we are going to discuss that one now. The first paragraph you read, that one you understand that if, for example, you are whirling a stone with a rope, right? That time,
Yes.
if you release it or somehow it is torn, then you will see it is going straight. The moment it was torn or it was released, from that point it is going straight, right? Isn't it? Hello.
Yes, sir.
So this one is said here that it is going through the tangent, right? Look here, the direction of velocity is with the tangent of the circumference of any point. We have this point here, and the tangent is drawn in this point. That is the direction of velocity of the object. This is about page 3. They are saying to take it in page 3. It is page 4. So at any instant, the direction of the ball's velocity is along the tangent to the circle. Okay, this one you understood, right?
Yes, sir.
Now here we have very important discussion to this one, to understand the centripetal acceleration formula is very important for us. You see here we have circular path from A to B. It's actually indicating this diagram, huh? A to B. One position is A of the object when you are moving the object around a circle or in circular motion. The first position is A, second position is B, for example. And to travel from A to B, we need some time, right? Isn't it?
Yes, sir.
That time we are thinking very small time as we are traveling from A to B, the distance, uh, the path, it is very small path. That's why we are considering the time is also very small. That one we are saying del t. Del indicates very small time. Del t, where VA and VB are velocities at point A and B respectively. So VA and VB are two values of velocities at A and B. The acceleration, what will be the acceleration? Acceleration is change in velocity, right? By time
Yes,
taken.
sir.
So change in velocity means VA minus VB, that is del V. So A equals del V by del T. A equals del V by del T. Is it clear now? Till here
Yes,
it
sir.
is clear. Now we are uh, going for more discussion. Then you will write later. Huh? We just finish it discussion. Then you write. You have to understand it first. If we consider del theta is very small, like we got previously in radians that uh, the arc is del s, then we have r here. The del s is equal to r, that is theta, right? Isn't it? Hello, hello,
Yes, sir.
Navid. Previously we got uh, s divided by r equals theta.
Uh,
Now it is del s by r. That's why it
R.
is del theta.
Yes,
Okay,
sir. Hmm.
is it clear?
Yes, sir.
Now we have then using similar triangles rule for triangle OAB and triangle CDE. We consider del theta to be greater than arc AB is a straight line. So this arc is a straight line, right? We are considering it straight line. How? Like um, I can give you one example. Like the earth um, is like round shape, right? Hello.
Yes, sir.
But
Can I
uh,
leave? I have class.
you have another class.
Yes.
Okay, so we will upload the recording. Okay, Asan,
Yes, sir.
you take the notes from the recording. Thank you so much.
Uh,
Okay, now if you are thinking of in front of you the level of the land, you see it flat, right? Isn't
Yes,
it?
sir.
So if sometimes we are going to the Cox's Bazar or any other place in front of the coastal
Ocean.
area, we have the in front of the sea, right? That time we understand that the level of water is uh, a bit round shape, right? As far as your eyes is going, the level of water is uh, it's not that straight the way you are seeing in front. It's a bit round shape, right? Isn't
Yes,
it?
sir.
So when you are taking very small sample or a small part of the even it is curved, then it seems to you it is straight. You are considering it as straight, isn't it?
Yeah, but it's carved. Yeah.
Yeah, but it is curved.
Yes,
Okay.
sir.
If you are taking very small sample, then it is straight, isn't it?
Yes, sir.
Uh, Also, we can think of like every day we are having lots of examples like that. Like you have bought one, uh, for example, you bought a pumpkin, right?
Yes,
Isn't
sir.
it? So the pumpkin is a round shape, right? But if you take a very small piece of pumpkin, then you cannot find that it is round shape. It is then straight, isn't it?
Yes, sir.
This way we can understand. Very simple from our real life also. So here, as we are considering the del theta is very small, then arc AB is a straight line. Okay, then using similar triangles rule for triangle OAB and triangle CDE, we take the CDE and OAB.
Yes,
We
sir.
how OAB we are getting from here, like this part AB we are considering as a straight line. That's why we are thinking this one is a triangle OAB. Now, how we get this one CDE or DCE, whatever you say, how we got that triangle? We got this triangle this way. You have a
So from
VA,
the
right?
tangent. Yes, sir.
Yeah, you have this position A. For this, we have a vector that is VA, right?
Yes, sir.
We are just replacing this vector here with VA, and we have another vector that is working in this direction. Hmm, that one we are showing it here VB, right? Hello, hello. So the path difference between these two VA and VB.
Yeah, hello,
What?
hello, sir. Can you hear me?
Yeah, yeah. Now I'm
Uh,
hearing you. So
okay, okay, sir.
VA and VB, you got the difference. How much? Del V, right?
Yes, sir.
That means they are resultant, or we can say their difference is giving us what? VA minus VB. They are working in the opposite. That means two different directions. That's why we are subtracting them. VA minus VB. It's giving us del V. Okay.
Okay, sir.
Hello.
Yes, sir.
Del V. So the angle uh, we are getting between this, that is del theta, we are writing here V and VB. The angle we are getting, that is coming del theta. Okay, so this one is giving us triangle CDE. So if we compare these two triangles, we are getting DE by CD, DE by CD, DE by CD equals AB by OA,
AB by OA.
AB by OA. Okay,
Yes, sir.
DE is del V, right? So this one is showing this part. Then del V by VA equals del S by R.
Yes, sir.
Then we write del V equals del S VA by R. Then del V by del T, we are dividing both the sides with del T. Okay, then we are getting del V by del T, del S by del T, VA by R.
Yes, sir.
Then we are having A, del V by del T is A, right?
Yes, sir. A. Hmm.
Then equals del S by del T is V, and
Bracket V by R.
V, here we have VA equals VB, as speed is uniform, everywhere for circular motion. It's circular motion, so speed is same everywhere, right? So VA
Yes, sir.
equals VB is equal to the average speed V. So it's coming A equals V square by R,
Okay,
right?
sir. Yes, sir.
Yes.
Sir, will there be any question from this derivation,
This derivation we
or it's
sometimes
just
you
for
may have.
understanding?
Sometimes you may have this derivation, but it's rare. From this topic,
Oh, okay.
we normally don't have any questions directly, but we have next topic, that is gravitational fields. There always centripetal force idea is used in gravitational field. That's why we are learning it. Okay,
Oh,
this is the
okay, sir.
foundation or basic,
Okay,
and
sir.
you will get combinedly the questions for gravitational field and circular motion. So our worksheet will be also on these two topics together. Is it clear?
Yes, sir. Yes, sir.
Is it fine for you?
Yes, sir.
Okay. So you please take these notes from here. You already drew this diagram?
Yes, sir. Sir, I can take those notes after the class ends, right?
Really sure?
Yes, sir. Because
So
I will have to take them again.
yeah,
That's
yeah.
why.
That's why you want to write later, right? And at
Yes, sir.
last we have some examples. Examples of circular
Okay, sir.
motion. Can you read this circular motion example?
When a ball is whirled round on the end of a string, we can see clearly that the tension in the string is making the ball accelerate towards the center of the circle. And number two, a satellite in Earth orbit experiences gravitational attraction towards the center of the Earth. This attractive force provides the centripetal force and causes the satellite to accelerate towards the center of the Earth. So it moves in a circle. 3. A charged particle moving at right angles to a magnetic field experiences a force at right angles to its direction of motion and therefore moves in the arc of a circle.
Yeah, Amit.
Yes, sir. Hello? Hello?
Yes. So you read this till here. Two question. Yeah, part two, right?
Yes, sir.
Example two. Then example
I
three.
read up to example 3.
Oh, I did not listen that part. You are
Oh,
muted, maybe. Then four. Example four.
okay. For a car traveling in a curved path, the frictional force between the tires and the road surface provides the centripetal force. If the frictional force is not large enough, for example, if the road is oily or slippery, then the car carries on moving in a straight line. It skids. Number 5. For cornering, which does not rely only on friction, the road can be banked.
Yes, continue.
The road provides a resultant force normal to its surface through contact between the tires and the road. Fv is equal to the weight of the vehicle, this maintaining equilibrium in the vertical direction. F a says that's h, right? Fh provides the centripetal force acting towards the center of the circle. Many roads are banked for greater road safety, so as to reduce the chance of loss of control of vehicles due to skidding outwards in the corner and for greater passenger comfort. Number six, the lift force balances the weight of the aircraft when it flies on a straight level path. In order to change direction, the aircraft is banked so that the wings are at an angle to the horizontal. The lift force now has a horizontal component which provides a centripetal force to change the aircraft's direction. Number seven, a centrifuge is used to separate particles in mixtures. More massive particles require larger centripetal forces in order to maintain circular motion than less massive ones. As a result, the more massive particles, so can you scroll up? Yeah. As a result, the more massive particles tend to separate from less massive particles. Motion in a so should I read this?
This one is the most important thing. Yeah, we have to understand it. Yeah, read.
Okay. Some Some theme park rides involve rotation in a vertical circle. A person on such a ride must have a resultant force acting towards the center of the circle. Consider a person moving round at a vertical circle at speed v. At the bottom of the ride, the reaction RB from the seat must provide the centripetal force as well
The
as.
reaction RB. Okay.
Okay, sir. The reaction RB from the seat must provide the centripetal force as well as overcoming the weight W of the person. The centripetal force is given by mv squared by r is equals to rb minus w. Rb is equals to w plus mv squared by r. At the top of the ride, the weight W and the reaction force RT both act downwards towards the center of the circle. The centripetal force is now given by mv squared by r, which is equals to RT plus W. So RT is equals to mv squared by r minus W. This means RT is less than RB. If V is not large enough, then at the top of the circle, the weight may be greater than the centripetal force. The person would lose contact with the seat and fall inwards. Example: a rope is tied to a bucket of water and the bucket is swung in a vertical circle of radius 1.2 meters. What must be the minimum speed of the bucket at the height point of the circle if the water is to stay in the bucket throughout the motion? So
Here is the
1.2.
solution. Huh?
Okay, sir. Huh.
This one is the speed. So this one is about the roller coaster. Right? Sometimes it's going opposite, right?
Yes, sir.
So that time, how this person is head is working down, everything is working downwards due to gravity. It should fall, right?
Yes, sir.
But it does not fall down. Why? Because of the centripetal force, right? Working over there.
Yes, sir.
So that one is shown here with equation R top, R bottom. Huh?
Yes, sir.
So it depends on V, how much the V is. If your V is not large enough, then
I will
that
fall
person will fall
inwards.
down. Okay, is it clear?
Yes, sir.
So here, what you have to write from your notes, this after this derivation, for this derivation, you do not need to write everything. Centripetal force, centripetal acceleration. You will draw this diagram. This diagram is done, right?
Yes, sir.
Then you will start from here. This diagram, okay? Don't need to write everything from here. Statement you do not write, just the diagram, okay? diagram
Yes,
and
sir.
the mathematical derivation till here you write. Huh? Then you skip the examples, only take the notes of this vertical cycle, motion in a vertical cycle. Okay,
Yes,
and
sir.
here also you do not need to write all the statement. You just draw this diagram, label everything, then write this derivation. Huh? Huh?
Yes, sir.
So after this you write another derivation. Huh? This one R top, and this one you have to write. Huh? Last part. This means from here to here, huh? Inwards. Before example.
Okay, sir.
Okay, last paragraph you have to write because here we have the most important explanation.
Yes,
Okay,
sir.
so today this much, huh? Today, till this
Okay, sir.
much, you please take the notes. Make sure you are taking the notes, huh?
Yes, sir.
It is a must. Otherwise, after some days you'll forget. Huh? You cannot apply
Yes,
the
sir.
ideas. It's very important. Allah Hafiz, huh? Assalamu
Okay, sir. Assalamu alaikum.
alaikum.